So today we're going to be in block 8. And in block 8, basically what we're going to be doing is we're going to be focusing on applying proportional reasoning in a recipe context. And we're going to be enlarging recipes using ratio tables and equations. All right. So our opening question, all right, it's kind of based off of page 7 right now. How could you make 3 times the servings and have it taste the same as this 1 quart of strawberry ice cream? What could we do?
Multiply.
All right, explain that a little bit.
Like multiply each ingredient by 2.
All right, that would make it go up to 2 quarts, right? So what would we need to do to make it 3 times the number of servings?
Multiply by 3.
Perfect. All right. Okay, let's say to us. Ooh, that ain't good. Right now, I don't need to give people zeros, do I? Y'all got to participate. Come on, help me out. All right.
He said we got times it by 3.
There you go, Jacaden.
I had my hand up. You ain't see me?
No, I couldn't see. My bad. Just put the raise the little man's hand up. You know what I'm talking about?
Got him.
Oh, he's not showing up?
If we switching off favorite class, like some class I got some.
I got you. Okay. That's okay. That's cool. Good job. Just talk up next time, all right? You did good. That goes for anybody if you had your hand up. I'm sorry I couldn't see you. All right. So, once again, they said that we could just multiply our recipe by 3. So what might happen if you don't change the amounts proportionally? Like say you had some of the amounts changed and some of them you didn't have changed. What would happen, Jacaden?
It will mess it up. Like if you put too many eggs, it will be
What would it taste like?
Eggs.
It would taste like eggs. That'd be pretty gross, wouldn't it?
Egg nasty.
Yeah, that'd be gross. Or what if you changed everything but you only kept a half cup of sugar? Would that be good ice cream? No, that'd be like school food. I'm just picking. All right. So, great job. Way to explain that. All right. So, before we play this animation, all right, I want you to think about increasing the recipe from the strawberry ice cream from 1 quart to 1 gallon. All right. So, how many quarts are in a gallon?
4.
4 quarts. That's correct. All right. So if you notice, our strawberry ice cream is in 1 quart, but we want to increase this recipe to 4 quarts. So what are we going to have to do in order to increase this?
Times everything by 4. Times everything.
Perfect. What if we wanted to decrease this recipe?
Divide.
Good. That's right. Yeah, we could divide it by maybe 2 or 3 or 4, or could we multiply it by a number that's less than 1, like a half or a fourth? Would that work, Halen? Not real sure? So I want y'all to think about this. If we multiply something by a half, is it the same as dividing by 2? So if we do 4 times 1/2, what do we get? Put that in your calculator. If we do 4 times 1/2, or if I said, what is half of 4, what do you get?
3.0.
Let's look. I'm going to do 1 divided by 2, because that's what 1/2 is.
I got 4. I got 2.
That's right. So I'm going to multiply it by 4, and I get 2. All right. So is this the same answer as doing 4 divided by 2? Yeah, it is. So I'm going to restate my question. Is multiplying by a fraction that's less than 1, such as a half or a fourth, the same as dividing by 2 or dividing by 4?
Yes.
Yeah. All right. So looking at this, what I want us to do is I want us to try to figure out what each one of these will be if we were to create this recipe so that it would work for 4 quarts. Trying to turn my light on. I got it that time. All right. So, looking at this, I want everybody to take the next 2.5 minutes to create our new recipe. For those of us that have forgotten how to work with fractions, remember, if you're using a calculator, say for instance 2/3, the way you would put this in your calculator is 2 divided by 3. That's 2/3. Okay? All right. So I want you to use that, and I want you to find out your answers now. Like I said, I'm going to give you about 2.5 minutes to do that. So at 8:12, we'll be going over this.
Mr. Martin, what list we on?
We're on block 8, which is on page, I believe, 31 in your workbook. Somebody tell us if that's right or not, or wrong. Should be page 31.
Yeah, it's page 31.
All right. Good to see you, Carter. I hadn't seen you, man. Good to see you.
Yeah.
All right. So everybody should be in page 31 of their workbook, and we're going to try to solve this right now. We're trying to take this recipe from 1 quart to 4 quarts. Okay, let's see what we got. All right, so let's start with Ajoyous. Ajoyous, what would you do to the 2 egg yolks so that you'll be able to make 4 quarts of ice cream?
I would multiply it.
By what?
4.
Perfect. So what is 2 times 4, guys?
8.
Good. So we're going to have
8.
8 eggs. All right. Jacaden, what are we going to do for 2/3?
2/3 times 4.
Perfect. So we'll do that. So what is 4 times 2?
8.
And then we need to divide that by our denominator, which is?
I ain't getting my phone died.
That's okay. What's 1 times 3?
3.
Yeah.
3.
All right. So all we got to do is see how many times 3 goes into 8. How many times does 3 go into 8? 2 times.
You go with 2 times.
Good. And then when we subtract, we're left over with what?
2.
2. So I got 2 and 2. What? What's our divisor? 3. Yeah, 2 and 2/3. Good job. All right, so our answer here for condensed milk is 2 and 2/3. All right. What do we do here for 3/4, Miss Emma? I'm going to use a different color.
Okay, so what I did was I multiplied 3 by 4, by 4, and then I looked to see how many times 12 went into 4, and then that was my answer.
All right. You mean how many times 4 goes into 12?
Yes.
Yeah. All right. So what'd you get?
3.
You are 100% correct. Great job. So we got 3 chopped strawberries. All right. Jamal, what did you do for a 1/2 cup of sugar?
So I did 1/2 over times 4.
Okay. And what's
That equals 4 over 2.
good? And what does that simplify to?
My phone did. My phone.
That's okay. What's 4 divided by 2?
2 is 2.
Perfect. That's the answer. That's pretty easy. You didn't need the phone, did you?
No, sir.
All right. All right. Haley. I'm going to give you the difficult one. Haley, what do I need to do to 1 1/4 so that I can multiply it by a number?
You need to take apart the 1 and make it 4/4.
Pretty close. You're pretty close. We're missing one step, but you're really close. Well, I tell you what, Haley, explain what you're saying. Jamal, cut your mic, buddy.
Because 1 equals 4/4.
Good.
And then if you would just take apart the 1, you could just add it to the 1/4. And then you could have got 4/4, and then you times it by.
We don't, if we take this apart and make 1 4/4, we don't do 4/4 plus 1/4? Would that work? All right, so let's talk about it. All right, so right now what we've done is we have taken this and we have pulled it apart. Sorry, I'm laughing at Jacaden. He's being something else right now. But anyways, I'm going to take those apart, and when I break them apart, 1 is 4/4, right? Since it's 4/4 and we have 1/4, if I combine 4/4 and 1/4, how many fourths do we have?
5.
That's right. So we have 5/4. All right. So that is the first step. So that means that 1 1/4 is equal to 5/4. Since 1 1/4 is equal to 5/4, now we just get to do what we did with all of the ones that we did beforehand. And so what did we do exactly? What did we multiply each one by? That's correct. So we're going to take 5/4 and we're going to multiply it by 4. So what is 5 times 4?
20.
Good. And what is 20 divided by 4?
5.
Good. So how many cups of whipped cream are we going to have?
5.
5. All right. Let's play this video and see if we did everything the correct way. I'm going to erase this as fast as I can. And then we're going to see what they came up with. But I think we all did it 100% correct because we're just that good. All right, so let's see. All right, does that look like the same answers we got? Yes or no?
Yes.
Yeah, it is. All right. How did they get their answers different than we did? What did they do?
On a cup of milk, they put 3 instead of 2 and 2/3.
Okay, now look at that milk though close. You got
One of them not full. One of them not full.
That's right. And so that's actually how they did their whipped cream also. Like when they were adding it together, they took the cups. And so they had pictures of the cups. And then they just added the amounts in each cup. And that's how they got 5 cups. So, we work on tables, we work with equations, and they worked with using pictures. So would all 3 of those ways work? Yeah. Whichever way is easiest for you is the one that I want you to use because that's what's going to help you get the right answer every time that you are asked a question, okay? So if you look at this, it says, this is the increased recipe. Proportional reasoning can even get you more ice cream, all right? So this is something you're going to use in the future. I know it doesn't seem like you will now, but one day you're going to be making something and you're going to have to either increase the recipe or you're going to have to decrease the recipe, okay? So This is a very useful set of knowledge for us to have, okay? So let's keep moving. Page 8. All right, so looking at this, it says now you can apply your own proportional reasoning skills to solve this puzzle about strawberry ice cream. You have an ice cream maker that can make up to 6 quarts of ice cream. Rewrite the recipe for strawberry ice cream so that you will make 6 quarts of ice cream. So if you take a look at what they have, you'll notice that we have the hint box, we got submit your answer, and you have a total of 10 of these to choose from. So right now, what I want you to do is I want you by yourself to work on seeing which one of these fits here. But before we do that, I want us to determine what our scale factor is. So Miss Layla, will you tell us what our scale factor is to make 1 quart become 6 quarts?
6.
100% correct. And the scale factor, who can tell us what a scale factor actually means? What do we do with that scale factor? Or what does the scale factor tell us?
How much we multiply by?
That is 100% correct. It is the number that we multiply our original figure by to enlarge or reduce to make our new figure or amount. In this case, we're talking about a recipe. All right. So the scale factor in this case is the amount we are going to multiply our 1 quart by so that we can make our new recipe greater for a bigger amount of people, or I don't know. I'm trying to think of the correct words. What are we trying to do? Make up to 6 quarts of ice cream. So to increase our recipe, that's what I'm looking for. So the scale factor here is going to allow us to increase our recipe so that we can feed more people. All right. So I think this is going to take a little while. You notice that we got 1, 2, 3, 4, 5 of them. And one of those is a mixed number, and 3 of those are fractions. So I'm going to give you a little bit longer this time. So I'm going to try to give you about 5 to 6 minutes. So 6 minutes from now would be 8:28. So at 8:28, we're going to check our work, okay? So make sure you're still working in your workbook. This is in your workbook. So make sure you're doing that. You are more than welcome to use your computer so that you can get a hint if you want to. And I'll check on you here in just a few minutes and we'll see what we get as our results. So we're going to see what we got. So let me call on a couple new people. Let's go. Let's start with Lainey. Lainey, what did you do to figure out? I'm going to call on you next, Jamal. Lainey, what did you do so that you could figure out how many egg yolks you would need?
I did 2 times 6.
Good. So if we do 2 times 6, what did you get?
12.
That is 100% correct. Good job. All right, so I'm going to try to pull this 12 right over here. All right. Jamal, I said I'd call on you next. Jamal, what'd you do to figure out the condensed milk?
Oh, that is 4.
All right, so how'd you get it?
It is I increased it by 6.
Okay, so we do 6 times 2 is 12, and 12 divided by 3, just like Jamal said, is what?
4.
4. Good job. So we're going to take this. We're going to pull that 4 right where it goes. All right. Deonti, tell me how we can figure out how many chopped strawberries we would have.
I multiply 3/4 by 6.
Good. So I'm going to do 6 times 3/4. What is 6 times 3?
18.
Good. So I get 18/4. But when I look at that, that answer is not up there, is it? I don't see
That
it.
turned into a whole number.
That's right. We got to change it. All right. Now, I don't think it's going to go to a whole number, but I know for sure we can make a mixed number out of it. So let's see how many times 4 will go into 18.
I got 4 and 1/2.
You are 100% correct. So 4 goes into 18 4 times, and 4 times 4 is 16. And when we subtract, we're left with 2, which is our numerator. So we're left with 4 and 2/4. And that was already told for us what that's actually going to equal. 4 and 2/4 simplifies to 4 and what? 4 and 1/2. So that answer is right there. All right, so we're going to get that and we're going to pull it over where it goes. And I'm going to get us some more room. And so while we're getting some more room, I'm going to see if Miss Faith can help us. Faith, how could we figure out how many cups of sugar we would need? What have we done to every one of these?
Times.
That's right. What have we been multiplying it by?
6.
Good. So what is half of 6? So if you had 6 and you cut it in half, so in this case, 6 times 1 is 6. So we're left with 6 divided by 2. So that means if we have a total of 6 and we split it right down the middle, so I just split that right down the middle. How much is on each side?
3.
That's right. So our answer would be what, class?
3.
That's
3.
right. Perfect.
3.
All right. I'm liking this. All right. Mr. Carter, I'm going to give you the hard one. What could we do, Carter, to solve how many cups of whipping cream we need? What do we have to do first to 1 1/4?
Turn the 1 into a 4 and make it 5/4.
That's correct. So we got
And
5/4. And now what do we do?
and times it by 6.
Perfect.
6 times 5 is 30.
Good.
And 30 goes into 4 only 7 times.
All right. 4 goes into 37 times.
And you're left over with 1/2.
That is
So
a
7/2.
100% correct. Great job. So he said 4 is going to go in here 7 times. 7 times 4 is 28. And when we subtract, 10 minus 8 is 2. We got to borrow from here, and this becomes 10. And so we're left with a numerator of 2 and a denominator of 4. And Carter's already told us that 7 and 2/4 is equivalent or equal to 7 1/2. Great job, everybody. So let's submit our answer. Let's see if we got it right. Look at that. It says, good job, it doesn't say we, but it says we for me. We have correctly increased the recipe because I didn't do it. Y'all did it. All right. So we all did a great job. I'm very proud of everyone that worked on that. Is there anyone that did not get these answers? Don't be afraid to say you didn't get these answers. I would like to work with you and help you if you got one of these wrong, or maybe I could find what went wrong so that we can get it right. Razai, how did it work for you? Did that turn out pretty good?
Yes, sir.
Perfect. All right. Is there anyone else that might have had some trouble? Militon, Roykia, Sarah, Tashandrick, how did it work for you?
It went good.
Good. All right.
It was good.
Did anybody use the calculator?
No, I didn't have a calculator with me.
All right. So I'm going to show you one easy thing very quickly. If we use this calculator You can actually work these problems really fast. So if I take the calculator, I'm going to put it right here. All right. And say, for instance, I want to figure out 3/4 multiplied by 6. All I do is 3 divided by 4 equals 75 hundredths, and then I multiply it by 6, and I get 4.5. Is that the same answer? All right, so that was pretty quick, right? So I can do the same thing with a half. So I do 1 divided by 2, and I get 5/10, and I multiply it by 6. Once again, I get that answer. All right. If I have some trouble, say for instance, this is 1 and 1/4. Remember that 1 and 1/4 means I have 1 plus 1/4. So I can take 1/4 and I can figure out what it is. And it is 25 hundredths. And I can add it to 1. So I get 1 and 25 hundredths, and I multiply it by 6, and I get 7.5. So does everybody see how we can work it by hand and we can work it by calculator?
Yes, sir.
Perfect. Which one's easier to you?
Calculator.
All right. Some people like using the calculator. I kind of like working with fractions just because I do it all the time. The more that you work with fractions, the easier they become. And so once you start working with fractions all the time, it's easier kind of to do it by hand. But if you know how a fraction works, and that means this is the numerator divided by the denominator, it is super simple to put it in the calculator, and you know you got it right every time. So both ways work perfectly. But I want, like I said, in everything we do, there's more than one way to get the right answer. But I want you to use the way that you feel most confident in getting the correct answer. Does that sound good to everybody? Good deal. I like all those thumbs up. All right, so we got some higher order thinking questions or STEMs. And so we're going to go with this one. How would you increase a recipe to make more portions? What would we do to increase a recipe? Someone give me an example.
Times.
Okay, so explain on that a little bit. Go into further definition.
Multiply what you have.
Okay, so say for instance, I want to double my recipe. What would I have to do?
Times 2.
That's right. What if I wanted to triple my recipe?
Times 3.
What if I wanted to
Times
quadruple my recipe?
Times 4.
Times 4.
All
Times
right.
by 3.
What if I wanted to
By 4.
half my recipe?
Divided by 2.
Yeah, I could divide it by 2 or multiply by 1/2. Good job. Y'all answered that perfect. All right. So why are proportional relationships, why are they needed to maintain the taste of a recipe? Like, what would happen if, say, for instance, I only put 4 eggs instead of 12 eggs? What's going to happen?
It's gonna be eggless. It's gonna be eggless.
Yeah, it wouldn't have enough eggs, would it? Would it taste the same?
No, sir.
No, it would taste disgusting.
Yeah, it would be gross. It would be gross. All right. So, is it important for us to, when we increase or decrease our recipe, for us to increase or decrease it proportionally?
Yes, sir.
Yeah,
Yes, sir.
it is. If we don't, it's going to be nasty. All right. So, we got a couple of constructed response questions on our block 8 activity sheet. All right. And so when you look at it, I think the first one that we have is question 3, A through B. So we're going to go, I'm going to pull that up on my screen now, but I want everybody looking at question 3, part A right now. That's perfect. All right, so let's look at A. Let's see who hasn't read for me today. Roy Kia, tell us about these yummy fudge brownies.
You want me to read measurements too?
Yeah, if you don't mind, that'd be great. And then I want you to read part A.
They use 1 cup of butter, 4 squares of unsweetened chocolate, 2 cups of white sugar, 4 eggs, 1 cup of all-purpose flour, 1 teaspoon vanilla extract, a half teaspoon salt, 2 cups of chopped walnuts. A, you have invited 7 friends over to your house. You want to bake a snack for everyone, including yourself. You decide to bake fudge brownie. You have a great recipe from your grandmother. The recipe makes 24 brownies, but you think you only want to make 2 brownies for each person, or 16 total brownies. You want your brownies to taste like your grandmother's. How should you change the recipe to only make 16?
All
Or you
right.
don't have 7 friends to invite.
Say that again, Jacaden.
If you don't have 7 friends to invite.
Well, that's just a bad situation. But this person does. All right. So my friends are like my family. But anyways, like my closest friends are my family. But anyways, so looking at this, think about if you're having like family over, or anyways, this person's having 7 friends over. Their recipe is for 24 brownies, but they want to only make 16 brownies. So what could you do?
Multiply by 1/2.
All right, if we multiply by 1/2, what is half of 24?
12.
So is that going to be enough? Would that be enough?
No, that will not be enough.
No, it's not going to be enough. I want you to think back to when we worked on the cathedral and we had to find the missing height. What did we have to do to determine that missing height? We found the scale factor, didn't we? So what could we do here to find a scale factor that would help us change this to where we would get the correct answer? What are we wanting to make it?
16.
All right. So if you can think back to that cathedral, we had to take the new measurement and the old measurement and we did something to them. What did we do?
Multiply?
It's actually the opposite of multiplication.
Uh,
What do we do?
Divide.
We divided. All right. So what is the new measurement, or what is the new amount of brownies here? What does she want to make?
16.
That's right. So what we need to be thinking is we need to take 16 and we need to divide it by what amount?
7.
24.
24.
12.
Not 12, 24. And so somebody use their handy dandy calculator and figure out what 16 divided by 24 is. All right, so that's actually 2/3, okay? So you would get 2/3, or you could say 666 thousandths. Jacaden, I don't know what you got, buddy. I think you added or something.
We had 16.
Oh, you had 60. It's supposed to be 16. There you go. All right, so looking at this. Hey, Zayden, you got to make sure you clock in a little bit earlier, dude. You done missed like most of the class. You're going to have to watch your video.
Yeah, boy.
That's all right. You can make it up watching that video. All right, so if you do this, 16 divided by 8 is what?
2.
2. And 24 divided by 8 is
3.
3. Good job. So we get 2/3. So this is actually the scale factor that we would need to use to do what?
Make 16 brownies.
That's right. So the question says, how should you change the recipe to only make 16 brownies? So in our case, what do we have to do with every one of these numbers?
Times
Multiply it by what?
2 or 3.
2/3. That's correct.
2/3.
All right. So I'm not going to take the time to do 2/3 times every one of these right now. That's something that we can do on our own time in a little while for our homework. But let's look at question B. Read question B for us to Chandrik.
You have decided to make a large batch of brownies for your soccer team. There are 24 people on the team, including you and the coaches. You want to make sure each person has exact 3 brownies. How should you change the recipe to make sure the brownies taste the same as your grandmother's brownies?
To Chandrik, I think they were impressed by your deep voice, man. All right, here we go. So, looking at this, there's 24 people on the team, but you want to make sure each person has 3 brownies because those people are hungry. All right, so if the original one makes 24, what do we need to do? What scale factor do we need to use to increase the amount of our recipe so that so that each person will have 3 brownies? What would we have to do? Chris, what do you think we would have to do, Mr. Christopher? You're 100% correct. We're going to multiply. What number would we multiply them by? That is correct. Great job. So our scale factor would be 3. So that means that we would take, for B, we're going to take every one of these and we need to multiply them by what? 3. Great job. All right. So everybody should see how to answer part A and part B. All right.